We are going to go over an inverse square law problem. In this problem, we have a spray bottle filled with red colored water. 4 sprays equals 3 milliliters of water, so each spray is 0.75 milliliters of water. We place a paper towel at 50 millimeters away from the nozzle and spray, and get a spray diameter on the paper towel of 60 millimeters. Then we place a paper towel at 120 millimeters and spray again. We get a spray diameter of 137 millimeters. Plugging those values into the area of a circle formula, we get these values for the area. Intensity is simply the amount of water being sprayed divided by the area of the spray diameter. I have listed the experimental values here. Keep in mind this is the average intensity. We want to determine what the theoretical spray intensity should be at the second condition of 120 millimeters away. So now, in order to complete this problem, we will have to learn about a thing called the inverse square law. We have to think in terms of there is at every distance a sphere that has a surface area of a sphere of 4 times pi times the radius squared. At our first point, which is our baseline, the total amount of liquid is broadcasted over an area of 1 square. At a distance of 2 times the distance from our baseline of radius 1, the liquid is broadcasted over an area of 4 squares. The amount of increase in area can be found by taking the surface area of the sphere at point 2 and dividing by the surface area of the sphere at point 1. So at this point, the intensity now is divided by the inverse square of the radius 2. Keep in mind that the radius is relative to the initial radius, so radius 2 divided by radius 1, not the measured radius. To further drive this in, we can think in terms of the intensity at point 1 is the source over the surface area of the sphere at point 1. To get the intensity at point 2, which is the source over the surface area of a sphere at point 2, we can multiply the intensity baseline by the surface area of a sphere at point 1 divided by the surface area of a sphere at point 2. Doing the same thing for 3 units away, we get that the intensity is 1/9 the intensity at point 1, or the inverse square of radius 3 relative to the initial radius 1, radius 3 divided by radius 1. Back to our problem. In order to solve this problem, we need to get our first radius into a baseline unit of 1 unit by dividing 50 millimeters by 50 millimeters, and our second radius of 120 millimeters by 50 millimeters to get 2.4 R1s equals the radius at point 2. Now we can plug in our radius 2 into the equation intensity at point 1 over the radius at point 2 squared formula. We get the displayed answer in milliliters per millimeters squared of paper towel on average. Plugging this into our experimental error formula, we get an experimental error of 10.6%. The causes of the experimental error could be the paper towel absorbance causing false measurements, the air resistance of the water droplets, and the difficulty of seeing every particle of water on the paper towel. Some examples of where the inverse square law is used is in radiation problems to find the intensity at a point, gravitational problems, and sound problems, to give an example of a few. Basically anything where something travels out from a central point in the shape of a sphere. That concludes this video. Hope you'll have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.